Hey guys, I'm going to do one more of these before I go home. We're going to be graphing the graph of y, p of x, and you can probably work out what type of equation it would be. And if I really wanted to, I could go through and say p of x must be x plus 1, x minus 1, x plus 2, or it could be something completely different. Who knows? Anyway, but that's not important. That's not what we've been asked to do. We've been asked to draw the graphs of the following polynomials. Now, guys, I'm going to do a very messy version of the graphs of this polynomial for the first one. Okay, so looking at this graph, we're going to say y is equal to negative p of x. Now, the y value and the p of x value, they're the same thing. So this is p of x, the curve, but we can also interchange the idea of p of x with y. So we're just saying that the y value is negative. So if this y value is negative, this one goes down there, this one goes down there, this one goes down there, this one stays still because it's negative. This one goes up there, up there, up there. So it's just like flipping it around the axis, around the x-axis. So it's going to look a bit like this. And I might do it in red. Okay, obviously mine looks pretty terrible, and it is a very rough sketch. However, I think we've got the idea. The x values do not change. However, the y values change their sign. So if it was positive, it becomes negative. If it was negative, it becomes positive. And it looks a bit like that. I'm sure it looks a lot better than what I've drawn. But you get the general idea. Okay. Now, if we move on to number, now that was, if I wanted to label that, I would label it as negative p of x, seeing as this was p of x. Alright, so for b, y is equal to p of negative x. Alright, so it's just like we get the y-axis and we flip it around. So we're going to be rotating it around the y-axis, which will give us values a bit like this. Instead of having negative 1 over here, we're going to have positive 1 over here. We're going to have negative 1 there and negative 2 there, and they're the points at which it's going to cross now. Minus 2, minus 1, and 1. Let's just keep going. So it's going to go down and that. Alright, so you can see previously it was getting the p of x was getting larger as x was increasing. Here you can see p of x is getting smaller as x is increasing. The value of the y-intercept has not changed, and that's it. Alright, so now make this a little bit smaller. And now I'm going to do C. So in this case, y is equal to p of x plus 2. Alright guys, whenever you add a constant to an equation, whether it's y is equal to x squared and then adding 2, it just moves it up. So everything here is just going to go up 2. The point at which it will cross over the axis, well, I don't really know right now. What I do know, however, is the point at which it crosses over here will be 5. So it's going to look a bit like this. Questions you might need to ask: does it actually cross over here and here again, or does it miss it completely? We can actually solve that question. Well, if we had the value down here, we'd be able to solve it. So if this is below negative 2, then it's going to cross over again. If this is above negative 2 here, then that means it's going to be above that line. I don't think that this question is really asking us for that much detail, though. Going through and doing question D, y is equal to 3 P of x. Now guys, some of you might remember from when we were doing Angry Birds that when you put a coefficient out the front of an equation, it just exacerbates it or makes it dramatically more bouncy. However, and here's the important part, the roots of the equation, or the points at which it crosses over the axis, do not change. It's going to be so it is all more dramatic. Now, this distance down here goes 3 times deeper than it did originally. So it's going to go, if I was actually to draw it, I'd probably look a bit more like that. It's going to cross over the axis at 9, because it's 3 times as big. And that's it.